Number 8 says, let f be the function defined by f of x equals x cubed minus 6x squared minus 15. At what value of x does f have a relative maximum? So if we're looking for a relative maximum on the graph, we're looking for a point that looks kind of like this. So you'll have a relative max if the function's value is greater than all the points around it. And you'll have a relative minimum if the function's value is smaller than all the points around it. So basically, if you've got a point that is at the top of a hill, it's a maximum, and at the bottom of a valley is a minimum. And so the way we can determine first where those relative extremes are is we need to find the first derivative. The first derivative gives us a function to define the slope of f at any point. And for relative extrema, and that's for maxima and minima, the slope at these points is 0. And so basically what we want to do is first identify where the first derivative is equal to 0, and then we'll find all the maxima and minima, but then we need to break it down a little bit further and find whether or not it's a maximum or a minimum. So I don't want to get too far ahead of myself. Let's first try to identify where the extrema are. To do that, we need to find the first derivative of x. We can use the power rule to do this. We don't need any special tricks or anything. The power rule, just as a little reminder, says that if you're trying to differentiate a term in the form a times x to the n, you're going to bring that exponent down and multiply it by the existing coefficient, so a times n, and then decrease the power by 1. So we'll do that for each term. For x cubed, if we decrease the power by 1, it becomes x squared, and we'll bring that exponent down, so we get 3x squared. The derivative of negative 6x squared will be negative 12x, and the derivative of any constant is 0, so we're just going to leave it like that. So this function defines the slope at any point of f of x. What we're interested in is when is the slope 0? So we'll set this slope equation equal to 0 and solve it algebraically. We can do that by simply factoring out an x and then setting each factor equal to 0 using the zero product property. So either x is equal to 0 or x is equal to 4. 3 times 4 minus 12 is 0. These may both be maxima. They may both be minima. You might have one of each, but this is where those relative extrema are going to be. Now, the next part is to identify, okay, we've got these points that might be relative maximum. We can go through and eliminate all the answer choices that aren't 0 and 4, but we need to figure out which one is it. Is it a maximum or a minimum? And to do that, we are going to use one of the two derivative tests. The first derivative test, and you can actually use either one's fine. The first derivative test basically tests to see what's going on with the slope around that point. So if you have a maximum, then the slope is going to be going from positive to negative. If you have a minimum, the slope will be going from negative to positive. So the strategy here, and I'm actually not going to work it out this way, maybe on another problem, because I think the second derivative test is a little bit faster. But what we would do is construct a number line, a little sign chart, and then just plug in values into the derivative to find out whether or not it's positive or negative on either side of 0 or 4. Okay, so that's the first derivatives test. Okay, you're going to make a sign chart and test f prime on either side of 0, but also 4. Okay, we're not actually going to work it out that way. We're going to work it out using the second derivative test. For the second derivative test, we, instead of trying to make a sign chart and plugging in numbers and all that, we are going to find the second derivative, and depending on whether or not the second derivative at that point is positive or negative will tell us whether or not it's a maximum or minimum. So if the second derivative is positive, that means that the function f is concave up. And we talked about this in a previous problem, but concave up is going to look something like this. And so that means that point we're going to have a minimum. If we test the second derivative and it's negative, that means that the graph is concave down, and therefore we will have a maximum. So let's find that second derivative, and then we'll test at 0 and 4 and see what's happening. So the second derivative, we can use the power rule once again on that first derivative. The derivative of 3x squared is 6x, and the derivative of 12x is just 12. So we got 6x minus 12. And what we're going to do is we're going to test 0 and 4 and see if we get a positive or a negative answer. Now, if you happen to get 0, then it'll be inconclusive, and so you'll have to fall back on the first derivative test, but this should work for most problems. F double prime, let's start with 0, is 6 times 0 minus 12. 6 times 0 is 0, minus 12 will be negative, so yeah, it'll be negative 12. That means, since it's negative, we have a maximum at 0. Okay, but let's test out 4 just to be sure. F double prime at 4 would be 6 times 4 minus 12. That's going to be 24 minus 12 is a positive 12. So therefore, since it's positive, we have a minimum happening at 4. Since the only maximum that's occurring here is at x equals 0, our answer is C.